Ken, is it okay if I take over or any more discussion?
That's fine for now. Go ahead, Vaughn.
Yeah, so we'll talk more about team later. It's actually interesting in the chat how many people talked about polite disrespect, which are definitely important. You want that. Um, I kind of mentioned this in the chat. One of the things you we'll talk about later is that still you want to have a team with open discussion, and that open discussion has to include, wait, is this the right way to go? Are we doing the right thing as a team? You want to keep it positive, but you do have to have those discussions of maybe we're all going in the wrong direction, or you're not meeting your commitments. It's a challenge. So that's something that Dr. Tallman and I often find that students struggle with, is when actually there are disagreements, or maybe the team's not going in a direction that's going well. And how do you open those conversations that are a little more difficult without destroying team spirit, but at the same time you got to have them. And in industry, I definitely found this is really key. If you have a team where everybody is super nice to each other, but they never say, hey, I think we're not doing well as a team, we're not going the right direction, that is not actually a high performing team. So your challenge is how to get both those things. It's fun, it's respectful, but it's also open, including saying, I don't think this is the right way to go. So, and the question in the chat, we will have more lectures where we're talking about this. Ken, I just jumped in there with a comment on that. I don't know if there's anything you'd like to say about that too, but that was something that struck me in the chat as an interesting trend.
Yeah, no, I think that it's very kind of important, essential in this course that we pay really close attention to these kinds of things, to team dynamics. Because as you said on Monday, the teams that are often most successful are the teams who figure out how to work together best. It's not necessarily that they have the best coders, but really that they found a working process that really kind of gets the best for everybody. And so that's a bit of a skill, right? It takes a lot of attention sometimes to get that to work. I see a few questions about the slides, Vaughn. Are your slides posted?
I think I forgot to post them before the lecture. I'll post them right afterwards. Sorry about that. So I think I can't post them now without delaying the lecture, so I'm going to move on. So I'm going to talk about version control in Git, which is what you're going to, you're learning that in the lab. So if you read the quick start guide already, you're using it, you're already familiar with some of this, but we're going to go through, why do we need Git and some of how it works. And then you can learn more of that in milestone 0. Okay, so let's talk first about what problem we're trying to solve. Okay, so we're building some software, and we've got multiple files. So I got 2 C++ and 2 header files here. And I'm going to pretend that I'm Tony Stark, or Tony Stark is one of the authors. So he's editing that first file. Okay, so he makes a change to it. He builds it, gets a program, tests it. What if it doesn't pass those tests? Okay, so maybe he made a change and it was bad. Now, if he made one change, he tested right away and it was bad, okay, maybe it's not too bad. He could reverse his changes. He can still remember what he did. But maybe he made a lot of changes. He was feeling good. He decided to make a big change, and then it broke the program, and he really regrets doing this. We want to go back to where we were before. This happens all the time in programming. Okay, so we need a way to go back to a previous version of the program. Okay, so is there any way to do this, any easy way? Okay, so don't say Git. The answer is going to be Git. That's why you're using it. But we're not going to use Git. We're not going to use something that's just like Git. There are competitors to Git. Is there something else we could use? Maybe we don't need to learn Git at all. Okay, so I see people saying Control-Z. So yeah, if we want to go back a couple of edits, Control-Z would work. But if I've been coding for a day in 20 files and opening and closing documents, Control-Z is not going to work. I see people saying, okay, have multiple saves, make backups. Good ideas, okay? And that's actually a poor engineer's revision control system, is to make frequent backups. I did that before too, before I learned about revision control. So we can make a copy of all our files really often. Okay, whenever you do something wrong, you switch to a backup copy. This actually works better than not doing anything, but it's not perfect. What are some problems with this? Well, how often do you copy all the files? Do you do this every 5 minutes? That could get pretty big. If there's a problem, And it turns out that you don't know when this problem was introduced. Maybe a day ago, maybe a week ago, maybe 2 weeks ago. Not quite sure. What backup should I go back to? I've been making lots of backups. I have hundreds now. What should I do to try to find where did I make this change? What if I forget? I got bored, I forgot, I didn't back up for a while. Maybe a day, maybe a week, maybe more. And then that's when I make my big mistake. So that's terrible. Okay, so we got a problem, and just regularly copying the files is not going to be it's not going to be a great solution. It's probably better than nothing, but not great. Okay, let's look at our second problem. Okay, so we still got Iron Man editing files, but now it's a bigger problem. He's collaborating with Batman, Bruce Wayne. Okay, so together they are making changes to this program, and Iron Man makes a change, saves it. At the same time, Batman is changing the same file, and he saves it too. Okay, so his save is a little later, so he overwrites Tony Stark's changes. Okay, they each build the program, test it, and it's confusing. It's confusing to Iron Man because his changes aren't there. They've been overwritten by Batman. Okay, so most programs are not developed by one person, they're developed by teams, so this is a big problem. Okay, so we need a way to prevent conflicting edits to the file. I don't want to have you overwrite my changes so they're gone. Okay, so have we got any simple solution to this? So if you never heard about Git, what would you do? So if you got any ideas, type in the chat. How are you going to solve this? Okay, so one thought is don't do simultaneous edit. That is a real solution. I mean, you could basically talk to each other, say, don't edit this file, I'm editing it. But it has some problems of scalability. Everybody has a certain time to work on the code. So yeah, you could divide up who's writing the code, who's writing in which file. So you can make this better with more organization, but you are now going to be limiting each other, and you need a lot of discussion to figure it out. Somebody's saying code on MS Teams or code in Google Docs. It's another option. If you put it in Google Docs, you can say, well, we're both editing at the same time, but we can both see what we're doing. That's probably a step forward too. So let's talk about this. Okay, so one class of solutions that people came up with is just don't edit the same file at the same time. So you email the other developers when you want to start editing a file, and then when you're done, you send another email. Or we could divide it up, who's doing what by certain dates, etc. So this does work better than doing nothing, but there are some problems. Okay, the person didn't read the email, so didn't know that she wasn't supposed to edit that file. Maybe you both send an email at about the same time. So you both think you can edit, but it turns out your email's crossed. And this problem also gets bigger as you scale to more developers. With 2 people, it might not be too bad. With 20, it's pretty bad. How are you going to organize this? The other thing people came up with is Google Doc or something like it, where everybody's editing in one document. You all see each other's edits at the same time. It has some improvement. You're not going to overwrite the other person's edits, but it's also really hard to. It's hard to manage. You're making changes in this file, and at the very same time, other people are editing different parts of it, or maybe even the same line. So you can still lose some edits. They just tend to be smaller pieces. So none of these solutions are really satisfying. They can help, but they don't give us what we really like. Okay, third problem. This is the last one I want to identify. So Iron Man makes a change to file 1. Batman makes a change to file 2. Okay, so there's no conflict in the file. They don't overwrite each other's edits. They both save, and then they both build, and they both start testing. Okay, so in this test, the program doesn't work. And the program doesn't work because maybe Iron Man just finished something that should work, but Bruce Wayne's in the middle of a whole bunch of changes that are half done. So Iron Man cannot test because Batman's in the middle of doing a bunch of stuff that's not finished. So this is really going to get in each other's way. This is going to impact their productivity because they can't test changes. So we need a way to control when our changes become visible to others. We don't actually want them to become visible right away. We want them to become visible when they're kind of a complete change set. Together, they work in a reasonable way. They don't break existing tests. Now other people should see them, integrate them into their code, and their tests should run with that new code. They should not get that new code when it's half done or not fully tested. And I don't actually have a simple solution for that. I can't actually even think of what would be. There's no solution that's even kind of halfway reasonable. Okay. So the solution to this is a version control system. And we're going to talk about a specific one called Git. All version control systems have a lot in common. There are certain differences. We're going to talk about Git in particular, but most of what we talk about applies to essentially all version control systems. Okay, so what's the key idea? The key idea of a version control system is you have local copies of files that are called your working copy. And that's what you're actually editing, that's what you're compiling, working with on your own machine. And then you have commands. So for Git, all of these commands start with the word Git that allow you to interact with a centralized repository. Okay, so this repository is where kind of the main version of the code, the committed, golden, most important version of the code is in this repository. So we have Batman is working on one copy, one working copy, can make any changes that he wants, compile them, test them, do anything. Tony Stark's doing the same thing, and only when they want to get changes from the other or send changes to the other do they actually use these commands to put their changes into this central repository. Okay? So that is the basic idea. We don't just have one copy. Okay, so we're going to start. How do we solve our three problems then? So I'm going to actually do problem 3 first, controlling when my changes become visible to others and when I get their changes. Okay, so you're working on your own copy. You can change things. So Tony Stark here has made a change to this red file. Can build it, get an executable program, test it, see whether he's happy with it all. Okay, and there's no interference from others. No changes from some other person are going to suddenly show up in the code that he's compiling and testing and editing. At the same time, Bruce Wayne's doing the same. So he's working on his own working copy. He makes a change to a different file, this green file, compiles it, tests it, etc. Okay, when your changes are finished and fully tested, you put them in this central repository. And that's done with 2 commands in Git. The first one is called commit, and the second one is called push. We're recommending that there are a lot of ways you can do this, but we're recommending that you basically do a commit and then do a push right away. I'm going to show you what each of those commands does in a few minutes, but you can basically use them one after the other, and that can be your development in philosophy if you wish. Okay, so what this does is like publishing them. It puts your changes in the central repository. Okay, so I've got some changes, I'm happy with them, they're tested, I do a git commit, then a git push. Those 2 commands together will put those changes in the central repository. And when he's ready, Bruce Wayne does the same. He does a git commit, a git push, and he's got different changes to a different file, and those will go in the central repository. When you want to update your code, so usually this is, I'm in a logical spot. I've made some changes, I've tested them, I've committed them to the repository, so they're essentially published. Now I'd like to see if anybody else made some changes while I was working. So you grab the changes from the central repository and integrate or pull them into your working copy. Okay, so Tony Stark's ready to, let's see what other team members have been doing. He does a command, git pull, and we recommend in this course that you use this -r option. Okay, so he does a git pull -r. And what that did is in his working copy, now you see he's got this green file. So it's pulled in the changes that Batman made and published to the central repository. Okay, Batman does the same thing, and he pulls in these red changes. He gets Tony's recent changes. As soon as you do this, what you should do is now compile and test, because you want to just make sure that, okay, I just pulled some new changes in. Let's make sure those new changes work, because if they don't, one of my team members did something bad. I want to know that right now before I make any changes, because I wouldn't be able to tell whose problem it is then. So good idea after you do a pull, immediately build, immediately test. Why do we have this -r option? It basically, I'm not going to get into the details of this, but it tells the pull the method by which it should bring in these changes, and it brings them in with a method called a rebase. It makes an easier to understand history of what's happened to the software. So if you have to go back to old versions, if you use this -r option, it is easier to understand what happened to the software over time. So that's why we recommend that you usually use that -r option, but if you don't use it, it works too. Okay, so I guess I already talked about this. Whenever you pull something out of the repository, you've made a change to your code, you pulled in your teammates' changes, immediately rebuild, retest because you want to know right now if there's a problem. Fix those errors right away. Okay, it takes much more time to identify errors usually than to fix them. So this is going to save you a lot of time, that you know the problem is the code I just pulled in. One of my teammates did something that he or she shouldn't have done, or there's some bad interaction. It's also the practice you want to get into is to do this commit plus push. So publish your changes frequently. Don't do a whole pile of changes and say, well, I'll just publish them all at once. And pull frequently. Bring in your teammates' changes. Every time you do a commit and push, you're publishing your changes. Every time one of your teammates does a pull, they're pulling your changes in. Whenever you do that, there's some chance of integration errors. Your teammates were changing something, you were changing something, and they don't quite play nicely together. If you do a lot of small pushes and pulls, it's you find those integration errors earlier, they're much smaller, they're much easier to fix. If you wait, you build up a lot of changes, and then you commit them all and push them all, and your teammates pull them all, the odds of problems are much higher, and they're much harder to figure out what's going on. So you waste time. Okay, so that was problem 3. Let's talk now about problem 1. We need to be able to go back to a previous version of the program. This is our backup problem. Okay, so what I just showed you, where you're publishing to the central repository, does this in a little bit more clever way than what I just showed you. So every time you do this git commit and git push, so you I've got some changes, I want to publish them to the central repository, we actually get a new revision. Okay, so initially we had maybe revision 1 here. After Tony Stark does this commit and push, we get a new revision, revision 2. So I can see that's got these changes, those red files, or that red file change. Bruce Wayne also does a commit and push, and what he gets is a revision 3. So we get a new revision that has, the red changes plus the green changes. So we've got a whole history of what's happened, and that allows us to go back if something goes wrong. Okay, so the older versions of the program all still exist, everything that you committed and pushed. After I've committed and pushed, again, I should do a git pull to get the latest code before I keep working. So I do that git pull, and it pulls in from this last revision the changes that Bruce Wayne made. Okay, Bruce Wayne does a pull as well, pulls in the changes that Tony Stark made. And now they can both keep working. So git pull-r is going to be one of the commands you run a lot. It updates your files to match the latest files in the repository. So that's the way you grab what have other people been doing on my team. Okay, so let's say I do this git pull-r. Okay, and as soon as I do that, I should compile and test to make sure everything's going well. And it didn't work. Okay, so I failed some tests. So, it's happened right after I did a pull, so I think it's my teammate. I think it's Batman who did this, but how can I prove it? Okay, so to prove it, what I can do is I can check out an old version. I want to actually take the last version before Batman made his changes and see if that works. So there's a pointer in Git called head. So you're going to see that word a lot in Git documentation. It basically is a pointer to the commit you're working with. And by default, when you do a Git pull, it says, go get that last commit and grab from it, okay? But we can actually also we can use other revisions if we want. So I can use a command called checkout. So I say git checkout, and you have to say, what revision am I trying to check out? So I want to check out revision 2. And the reason so that basically says, for my local working files, I want you to update them by basically grabbing this revision 2 from the repository and making my working files a copy of that. Okay? All right, so when I did that, this head pointer, which says what commit am I pointing at, gets changed to revision 2. And my local files, my working directory files, become a copy of that revision 2. Okay, so you can see now Bruce Wayne's changes are not there anymore. So I've gone back to an old version of the program with this command. I build it, I test it, and it passes. Okay, so that works. So now I've got strong evidence that it was actually this revision 3 commit that was made by Bruce Wayne that is the problem. I can send them an email saying, you got to go fix this. Okay. So it's giving me the ability to backtrack. It's giving me the ability to test out older versions of the code. I see there's a question, how many revisions can you save? It's infinite. Git just keeps saving them. It'll never delete revisions unless you ask it to delete revisions, which is considered bad practice. So you basically just saves everything. Okay. Okay. Note that you will not be able to update or commit to an old revision. So this Git knows that this head pointer is no longer pointing at the last revision. There's another revision after it. So if you try to commit, it's going to say you're in what's called a detached head state, saying this doesn't make any sense. You don't want to do this. You're going to commit to a spot where there are still changes after that. Okay. So to get back to a state where you can actually make changes again, you've done your experiment, you figured out that this revision worked, whereas this one didn't. You do git checkout master, okay? And that basically is going to get the last commit and make your head pointer point at it. So it gets back the latest code, makes your head pointer point at it, and you can now keep editing, keep changing. All right, so this is a common thing if you do the git checkout that I showed you to look at some old revision. Afterwards, you start getting these messages saying I can't commit. It's because you're pointing at a revision that's kind of got things after it. So you have to do this git checkout master to get back to a spot where you can actually commit again. So that's your demoing milestone 0. This can definitely happen because your TA might ask you to check out an old revision. Don't forget, if you need to make changes after that, you do this git checkout master to point to the last revision again. All right. So what have we done? We figured out that revision 3 is bad, but now I just told you to check it out again anyway. So now your working copy is still a copy of revision 3, and you're pointing at revision 3, which is like the tip of development, the last revision. But I know this was a bad change. I want to get rid of it. I've proven it's a bad change. The way you do that, there are multiple ways, but the cleanest way is you use the git revert command. So let me show you what that is. So I type literally this. I say git revert that commit revision 3. And what git does is it basically does the opposite. It gets rid of all these changes and it makes a new commit. So there's now a revision 4. That revision 4 is at the end of development. There are no commits after it. It's at the tip, so I can keep working. But that revision 4 has taken all of Batman's changes out by basically undoing them all. Okay? So that's the right way to get rid of I don't like this commit. And I'm going to show you why in a minute, but you actually type 2 commands. You type git revert to undo the commit, and then git push to make sure the repository is up to date. All right, after you do this, you again should build and test. You're going to build and test a lot to make sure that things are always working. If you don't know, well, what are all the revisions? Who's been doing what? You type the command git log. Okay, git log shows a list of all the files that were modified by every commit and the messages that were entered by the developer when he or she made that commit. Make those messages meaningful. Your TA is going to look at them, and you will, get more marks for style if you make good messages and fewer if you make bad messages. They help you figure out what's going on if you have a problem. What did Bruce Wayne do in revision R3? That may help you figure out if that's one you should check for bad code or not, if there's a bug. Your TA is also going to be much happier if he or she sees a lot of small commits rather than one big commit that says milestone 1 done. That's going to look bad. You're going to lose style marks. It's not a good way to develop. Okay, so that git log shows you what are the revisions, along with what files were changed, what messages were entered. If you say, okay, well, from the message in R3, I saw that was changed by Bruce Wayne, and he made a change that seems kind of suspicious to me. You want to know more about it? You can use commands that are talked about in the Quick Start guide. You can use git diff. So git diff, you can say, tell me what changed between revision 2 and revision 3. So that's what this command would do, and it'll show you all the changes. So it'll tell you what happened in this green update. Or you can type git show R3, which is just going to show you okay, what was done in that commit? Exactly what were all the changes in the files? So both of those can be useful to figure out how is the software evolving, what exactly changed between these two revisions. When I type git diff, what does it show me? You'll get output that looks like this. So this diff is showing me I'm in a file called file2.cpp. That was one of the files that Bruce Wayne and Tony are working on. I am showing you some differences that occur after line 192, and they're in this function called superhero setup. All right, this hasn't changed. This is just kind of context so you can figure out where are you in the file. The plus is basically revision 3 has this line, okay, that Batman is the best. And the minus is this line used to be in revision 2, but it's not in revision 3. So the meaning of this is basically revision 3 added this line and it removed that line, okay? And Iron Man considers this to be a bug, okay? So now he's located in this revision, that is the bug. Okay, so we already had this question. Doesn't this take lots of storage? And basically, no. Only the changes are stored between revisions, so it's not too bad. So even for huge programs, the changes between revisions are typically small. And if you're a good developer, they're always small because you're committing often. So what that means is even if you have lots and lots of revisions over time, the repo is not tiny, but it doesn't grow nearly as fast as you might think because it's being clever. It's storing just the changes and it can work out how to recreate things. Okay, so we still have 2 of our 3 problems. The last problem was problem 2. How do we stop conflicting edits to a file by different people? There are 2 basic approaches. One is called lock-based. This is essentially like send the person an email saying don't edit this file. Older revision control systems, there's one called RCS, one called VCS, use this. So basically you would type a command that says, I'm locking this file. Now I'm allowed to edit it. Nobody else is allowed to edit it. When I'm done, I commit the new code and I undo the lock. These systems are basically obsolete. Don't use them anymore, okay? Basically the second generation of revision control systems, and Git is one of these, are merge-based. So what they do is they don't lock. They allow as many people as want to edit the same file at the same time because they're all working on different working copies. And they only sort out what to do and like how to make all those changes work together when you actually commit and push the changes into the repo, okay? And that's how Git works. Other revision control systems like SVN work the same way. So let's just take a look at, well, that sounds a little chaotic. So basically different people are actually editing the same file and then trying to commit it. What happens? Okay, so let's say Iron Man has basically checked out the code. All right, so he's got a copy of a certain revision in the repository, and he's working away on it. And Batman's done the same. So they both take the revision 1 code, they do what's called a checkout, and they start working, they're editing, they're changing, they're testing. They're both happy with what they've done. So Iron Man does a git commit and a git push to move these red changes into the repository. Okay, so it updates, makes a new revision called R2 with those changes. Okay, now Batman tries to do the same thing. He wants to do a git commit and a git push. It's going to get this slightly funny message. It says can't do fast forward merge, and it will refuse to do it. The reason is Git knows that his code is based on revision 1. So he took a copy of revision 1, and there's now a revision 2. So Git will not allow him to commit his changes because he's not up to date. So what he has to do now, and you're going to get this message for sure. What he has to do is he has to do a pull. So he does a pull that updates his working copy code by pulling in any changes from revision 2, and Git says, now you're based on revision 2. You're up to date. You should immediately build, should immediately test to make sure everything's good. If it is, he can do his commit and his push. And that will create another revision, revision 3, that has his changes in it. Okay, so guaranteed you will get this message. That's what it means. You're not up to date. You need to do a pull before you can commit. Okay, what I just showed you is they were both modifying different files. So that works pretty nicely. What if they modified the same file? Okay, so if they both modified the same file, which is what I've shown here, Git's pretty clever. So same thing happens. He gets told I can't do a fast forward merge because Iron Man has already made a change. He does a pull. If they each modify different lines, Git is smart enough to just say, okay, well, Iron Man changed some other parts of this file. So I just changed them to Iron Man's copy because that's more recent. But I kept all your changes too. Okay, at that point, definitely, Batman should, this is why you build, why you test. You make sure that the changes, Git could figure out who made what changes and integrate them, but doesn't mean the code still works together. So immediately do a compile, do a test. If it all works, then you just do your commit and your push and you're good. The last and most tricky case is what if some lines in the same file were modified by two people? So now we've got these purple lines. So there's some overlap of certain lines were modified by both Tony and Bruce. In that case, Git can't figure out what to do. You both made changes to a certain line. They're not the same. It's called a conflict, and you now have to actually edit the files to say what happens. So it's not the end of the world, but it does slow you down. This is one of the reasons it's still a good idea to talk to each other about who's doing what. So you're trying not to edit the same subroutines at the same time, and also do commits frequently. So you don't have too many changes that are lying around that your teammates don't have yet. This is what a conflict looks like. So if you had a conflict like that, when you do the pull, Git will tell you have some conflicts. And in those files, you'll see lines like this. So this was my original file 1.cpp, right? It said Batman and Iron Man are the best. And in the new file 1.cpp that you have after the pull, it's going to show you these conflict markers, these funny looking blue texts. So this says in one copy, this is Batman's local copy, this line says Batman is the best. In the other copy that I just got from the repository, it says Iron Man is the best. It's the same line. Git does not know what to do. You have to edit this file to resolve this, right? So maybe you'll go back to this line. Maybe you'll delete both lines, just saying, let's stop arguing. And after you've figured out what the code should be, you remove these conflict markers too, okay? Follow the instructions in the quick start guide. It tells you how to do this. There are a few steps. So you will get conflicts. It's not the end of the world, but by communicating with your teammates and committing often, you'll minimize it because it's kind of a waste of time when you're resolving them, even though you have to do it sometimes. Once you've deleted these conflict markers, figured out what code you should have, go to the Git quick start. It tells you what steps. There are a few steps you have to do to tell Git, I'm done, and to complete the pull. Okay, I'm gonna end there. Well, okay, maybe I'll go for another couple minutes because it'll be helpful in milestone 0. So this is recorded, so feel free to log off if you got to go. I've been showing you a slightly simplified version of Git, which basically applies to all merge-based source code control systems. Git has something that is a little unique but powerful compared to most other revision control systems. It has not just one repo, which is what I was showing you. It really has a local repo and a remote repo. Okay, so there's one more level of detail. So now I've got two developers. There's only my two developers now I'm going to call Alice and Bob. So Alice has got a working copy, Bob's got a working copy. We have this, what I was showing as kind of the central repository is called the remote repo in Git. So that's kind of essentially the most important copy of the code that everybody has access to. And then it's given the name origin in your project. That's the typical name that we use for the remote repo. And it's stored when you're working as a team, it's stored in some shared directories that you all have access to, although you don't have to really worry about that. You also, on your own computer, will have a local copy of your repository, and every one of you will have your own. So you each have your own working copy on your machine. You'll each have your own local repository on your machine, and you'll have one shared remote repository. Okay, so why is this important? This is why we have to do a commit and then a push. Commit actually talks to your local repository. So it basically takes changes you've made and puts them in your local repository. When you do a push, they're moved to the remote repository or copied to the remote repository. Okay? If you do a git status, that asks Git what's going on, what changes have been made, it only talks to your local repository. So Alice has made a change to this red file, she's committed it to her local repo, she pushed it to the remote repo. when Bob wants to see what's going on, is there anything, what have I changed versus what was in my repo? Git status only talks to his local repo. It will not see the changes that Alice made. Okay? When he does a pull, that's what brings in Alice's changes. So that's why it's a good idea to do pulls often. Okay, that's where I'm going to end today. So yeah, the reason that Git uses this local and remote repo is basically for scalability. It allows Git to scale to a very large number of developers. It also allows people to work and actually do commits. So they're actually making revisions of their code, even if they don't have a network connection. Okay, so it's useful in a bunch of ways. It does mean you have to kind of keep track of most Git commands are just talking to your local repository. Only a few, like push and pull, are communicating with the remote repository. So you have to bear that in mind sometimes to interpret. If your teammate made a commit and is saying, grab my commit, and you're typing git status saying, I don't see it, it's because that commit and push went to the remote repo. You need to do a pull to bring it into both your local repo and your working copy, the files you're working with. Okay. So anyway, so I'll end it there for today, and we'll talk a bit more about Git on Monday. And I'll stay on the line to answer questions, but feel free to